And it seems we have an optimization talk schedule because next is Burt from Dorset. Hello, Tim.
Hello, how are we doing?
I'm fine. Everything is working great. And welcome to the Stripecon. And you're telling us about optimization in the front end, when I understand it correctly.
That's right, yeah.
So have fun on the stage.
Okay, hopefully there's my slides. Right. Hello, everyone. Good to be back. I hope you're enjoying the convention so far. I'm going to talk today a little bit about front-end optimization, which is a bit unusual for me because I'm primarily a back-end developer. Those of you who hang around the community Slack channel, community forum, will probably have spoken to me at some point. And I've also got a few modules out there on GitHub. I don't know, actually a few of the people here have contributed to those modules over the time, so thank you if you have. If you've ever spent any time talking to me, you'll know I'm pretty basic when it comes to things like this. I like simple solutions. So this talk very much is not going to be like most of the other talks you've heard. There won't be lots of cutting edge technology. This isn't the magic answer to all your performance prayers, but the whole thing really is motivated from a desire to address the change which came in with Core Web Vitals, and try and find some solutions which were simple, straightforward, and most importantly could be backported into existing projects to some extent without needing a complete refactor of the whole thing. So what we're going to cover today, just very briefly, are kind of the basics of what this is all about and why it matters. You'll find it's all very Google-centric. Google is the driving force behind all of this, and whilst that has got its pros and cons, what we found in terms of actually the real world is that this does make a real difference to a real user. So if you implement these things, if you use these as a measurement, as a guide to go by, then you'll actually get real good results from real users. So we're going to talk about ways to look at this, some basic strategies to approach it with. We'll have a quick refresher on the Silverstripe Requirements class and cover some real world examples of how we can actually implement some of these things. So straight into it, because I know we're running late today a little bit. So what are the Core Web Vitals? Well, back in May last year, Google published a blog post with a snappy title of Evaluating Page Experience for a Better Web. Now, page experience is one of those mysterious Google measurements that they use as a ranking factor, and it's quite a significant ranking factor. Up to now, it had covered things such as whether your pages were mobile friendly, whether they loaded over HTTPS, and whether they had pop-ups, interstitials, all that kind of nasty stuff that Google really don't approve of. So May last year, they announced they were actually supplementing the page experience signals with this whole thing called Core Web Vitals. And the size of the box, this diagram is straight off of Google's blog post page. The size of the box is actually significant because it does represent a big influence over the page experience score, and hence as an ongoing ranking factor. And it's broken down into 3 primary areas, and each one of those areas has got its own score that goes with it. The first of those is loading, and you'll see LCP, largest contentful paint, is kind of the thing they primarily measure in terms of loading. So this is about how the page is rendering for your visitor, for your site visitor. The second is the interactivity of a page. So this is measured with a metric called first input delay. There's lots of these acronyms, so get used to them. So FID, first input delay, it's how quickly your page becomes interactive to the user. And finally, the visual stability of the page, which again is you can probably guess what it means. We'll cover that in detail just in a second. So these three things together give you sort of an overall core Web Vitals value, and that gets pushed into the page experience algorithm, and that will affect positively or negatively the ranking for any given page, and obviously overall a site as well. We'll just deal with them one by one very briefly. All of this information is available on the Google website. There's a link down at the bottom of the slide there. So if you want to understand this fully, that's the place to go. I'm going to cover the headline version of this today. So we'll start with LCP, largest contentful paint. Google says the largest contentful paint metric reports the render time of the largest image or text block visible within the viewport relative to when the page first started loading. So just absorb that for a second. But essentially what it means is the biggest thing, the most prominent thing within the page that the user is looking at when they land on a site, that's what we're measuring. So how quickly that appears on the site. So the assumption being that the largest contentful element is one of the most important things you want your visitors to see. Now you can see there's the guide. This again just came straight from Google. So if you can deliver your largest contentful element in less than 2.5 seconds, you'll be ranked as good. Under 4 seconds is needs improvement, and beyond 4 seconds is poor. 2.5 seconds is actually quite a long time to be sitting there looking at a web page, but you can lose those seconds very, very easily if you do a few things wrong. Moving on to FID, first input delay. Okay, again, this is another one where the official explanation is a bit wordy, but basically it says FID measures the time from when a user first interacts with a page, when they click a link or a button, to the time when the browser is actually able to begin processing the event handlers in response to that interaction. Very, very long-winded thing. Now, in general, the input delay, input latency, happens when the browser's main thread is busy doing something else, so it can't respond to the user input. Quite commonly, that could be something like downloading and parsing a big JavaScript file. So you've got a big JavaScript file that contains all of your application code. It's got to read and parse all of that before it can go off and respond to a user request in case the JavaScript is telling it to do something else with that user request. So first input delay can be very much affected by the way your assets are structured. And this one is much, much quicker, 1/10 of a second. You've got to be under 1/10 of a second to have a good rating. 1/3 of a second needs improvement, and anything over that is bad. You'll be marked down for it. So this is one of those things that actually those milliseconds disappear very, very quickly when you start to get a lot of assets and resources into a page. Finally, we'll go on to CLS, cumulative layout shift. It's a bit of a mouthful, and the explanation for this, I'm going to give you the first 2 sentences of it because it's about 2 paragraphs, the official explanation. So CLS is a measure of the largest burst of layout shift scores for every unexpected layout shift that occurs during the entire lifespan of a page. A layout shift occurs anytime a visible element changes its position from one rendered frame to the next. Okay, it's very complicated, it's lots very wordy, but the fundamental essence of it all is that if your page reflows within the visible window, if your page reflows whilst it's loading, that's bad for your CLS score. If your page renders quickly and fills in the gaps, that's good for your layout shift score because it's not moving around. So this is about visual stability for the user. And this is a score. It's a fairly meaningless score. All you can do is compare it, one-on-one. 0.1 is good, 0.25 needs improvement, anything over that is bad. So we've got lots of numbers, and again, some of these particularly don't mean anything else beyond this system. So we need to have a quick look at what testing tools we can use to measure these and hopefully to give us some ideas about what we can fix. Now, probably you're familiar with a lot of these tools already. They fall into two categories. One are what they term lab tools. These operate in an artificial controlled environment, so they should give you repeatable results every time. And then you've got what are called field tools, and these are gathering real data from actual users out in the big bad internet. So the lab tools you're probably familiar with. Chrome Dev Tools can give you information about the load order of the markup, how quickly the DOM gets loaded, how things are being executed. There's all kinds of timing data in there as well. So your dev tools shipped with Chrome, with Firefox, all kinds of things like that. They're fairly standard and we probably all use them every day. We've also got Lighthouse, and Lighthouse is a performance measuring environment that kind of powers some of the other tools within Google. Lighthouse, I think, is now shipped by default with Chrome DevTools. You can run a Lighthouse report in there, and again, you'll be familiar with the output of that. You've also got external services such as a web page test that does similar things. That will give you waterfall diagrams, network diagrams, that kind of thing, to show you what's actually going on within your page as it loads. We then move on to the field tools. Now, Chrome User Experience Report is a system whereby Google gather data from real users en masse, and it's a huge data set. It uses Google's BigQuery and all kinds of stuff like that, and it gathers all these metrics together, attaches them to pages so that you can actually analyze specific breakdowns for specific pages with a huge variety of test environments, mobile networks, slow networks, different devices, all those kind of things. You get access to those things through Google PageSpeed Insights. Now, PageSpeed Insights, again, you're probably familiar with it. It's powered by Lighthouse Engine, so it runs those same tests that you can run in your local environment, but then it throws into the mix all of this real-world user data, the user experience report, the page experience reports, and it adjusts the results accordingly. So it's well worth making sure that once you've done local tests in your lab environment, that you actually get out there and run it in PageSpeed Insights as well. Search Console, again, if you're familiar with Search Console, PageSpeed Insights scores, page experience scores are actually now included as part of Search Console. So, and analytics as well. So actually, one of the things which really kicked this process off for us were our clients suddenly seeing in analytics, oh, there's a page speed report. And over the past 6-8 months, our page speed has been changing or going down or going up. So that started the conversation actually and started us along this process. So just going back to PageSpeed Insights, obviously you're probably familiar with PageSpeed Insights and the way it works. It gives you an overall score, big number at the top, but more importantly, it provides really good breakdown of detail, broken down by Web Vital type. This is a score from a live site. This is what we want. We want a nice big green 100 and green numbers all the way down through the various Web Vitals. Unfortunately, this is what we usually end up with. If you, especially with legacy sites, if you've got older sites, this is one of the worst I could find, it has to be said. So this has obviously got some really low scores, and it's got some very specific problems right across the board. It should also be noted, actually, these are both mobile tests, so there's a different set of criteria, slightly different reporting for desktop and mobile. Mobile always comes first because Google very much are about mobile first. So when we run a page speed test and this is what we get, we have to come up with some ideas as to how we can fix it. So looking at some basic strategies, again, this is probably stuff you already know. It's stuff that's a lot of common sense, and most importantly, PageSpeed comes to the rescue. It tells us very clearly where the issues on the sites are, and gives you some hints as to about how you can fix them. So this is the breakdown report of that site we just saw the score, the 15 score on. And we can see straight away from that list, there are some big wins that we can have, really, really big wins. And actually looking at the list, experience tells us that these are probably quite quick wins. The site in question is very image heavy. It's a big long page. It's got lots and lots of images on there, and rather helpfully, the client has chosen to upload a lot of PNG images into those image slots. So PNG images, obviously very high quality, but they don't compress anywhere near as well as something like JPEG. So one of the things you see very much here is it's asking, PageSpeed is saying, you should be serving images in next generation formats. So it means things like WebP, JPEG 2000. And further down in the diagnostics, it's saying you should be avoiding enormous network payloads. So the payload for this page really is 13 megabytes. That's all coming from these massive images, which may be 2 or 3 meg each, and just aren't optimal for that page. You'll also see in there that there are some big warnings about main thread work. There's a lot of main thread work going on. There's unused scripts in there. So there's a lot going on that we really can look at and really fix. And most of these are true for any site. So kind of here are the headlines about the things that we need to look at in order to improve these scores. First and foremost, eliminate redundant code. So if you've got, this site was a good example, on one of the pages, it's got a map. It's got an embedded map using a library. Now, currently the way the page was built is that the JavaScript for that map is actually included at the main template. So it means it's added to every single page, regardless of whether there's actually a map on there or not. Now, in terms of network traffic, obviously, generally you'd only have to download that once and the browser will cache it. But every single time that page gets executed, the JavaScript is passed, it's read, and that obviously is bad for your first input delay time. We want to cut down the amount of work the main thread is doing for no good reason. This particular site very much would benefit from delivering images in the right format and from specifying their dimensions. So 2 things here. As we said, PNG image is really bad for this particular use case, and there are better web efficient formats we could use. So if we can swap those images over to a better format, that will definitely improve our loading speed because the overall payload will come right down. That knock-on effect is good for our first contentful paint site because the browser has got the image, it can get it rendered much, much more quickly. Specifying the image dimensions is a really important thing for CLS, cumulative layout shift. If you tell the browser this image is this size, it can allocate that space on the page. So it knows how much vertical space it needs to allocate for the image when it arrives. And when it does arrive, it can plop it in without having to reflow your page. Lazy loading. Bryn actually talked about this very briefly yesterday, and we'll touch on it in a second, but wherever possible, we should be lazy loading images. Images which are out of the viewport, we don't need them. At the first point when the page is loading, we don't need them. So if we stop those images from being loaded, it means the browser can prioritize the images which are needed. So if there's 20 images on the page, but only 2 of them are visible, the browser can concentrate on getting those 2 and putting them onto the screen. So again, that's good for reducing the bandwidth. It allows the browser to get on with those priority tasks. And all of those things are good for first input delay, largest contentful paint, and cumulative layout shift. So lazy loading is actually, it feels like one of those really minor things, but actually it's got some really powerful effects in terms of overall page performance. Prioritizing visible content is another one you'll have seen pop up probably in the PageSpeed report. And this again is about making sure that for any given page load, the stuff that's on the screen at the start is prioritized. And again, I'll talk through some examples of that in just a second. But basically, the more help you can give to the browser to render the visible area first, the better all of these scores are going to be. So, just to put this into context a little bit now, Silverstripe Requirements class, it's been part of Framework for a long, long time, and it's actually a really powerful tool if you use it properly. You'll find it in Silverstripe View Requirements, that's its full class name. There's a link to the API down at the bottom. And what it allows you to do is during the complete life cycle of a request, so a page request will come in, during the complete life cycle, requirements can add resources that are needed to render that page when it comes out of the other end. And that can be done by any component. So it becomes actually a really, really powerful way to build a very specific set of resources for every single request that you receive. And the point is, this is done in the application. So you don't have to have complex front-end builds. You can plug this in to existing projects. You can build projects in a quite straightforward way, and you can do it in a modular way. So if you suddenly then add something in at a later date, requirements can just say, okay, well, you need some extra stuff for this. I'm going to throw that into the mix as well. It's a fair-sized class. I have to admit, I use 3 methods most of the time, and actually probably 2 methods most of the time. There's the CSS method, the JavaScript method, and the JavaScript template method. There are others in there, and they do cool things, but this is mostly what I use. There are also template versions of these. You can actually include requirements from the template too. And once this is all built, they get output in a very specific order. So starting off with, for example, if you've got a global page controller, the default page controller, if you put requirements in the init method in there, they will be output first in the resultant markup. If you've then got a page-specific controller, so maybe a home page or it's an elemental page or something like that, anything that's in that page controller, that can introduce requirements as well. They'll be output next. And then let's say it's got an element page. Individual elements can also output specific requirements as well. So they can introduce their own specific CSS or JavaScript into the stack, and that will get output at the bottom. Requirements does some clever stuff as well. It allows you to deal with deduplication. So if something tries to introduce the same CSS file or JavaScript more than once, requirements can deal with that. It will just say, well, I've already got that. I don't need to add it to the stack, and away we go. In conjunction with requirements, we also have a few other useful tools that I use, and this is now moving more into the real world end of the situation. These are all community modules, so that's good. And again, I know some people have contributed to these. It's all it's all gratefully received. The first one is an enhanced requirements module. It's one of mine. I wrote it to add some extra functionality to the standard requirements system in Silverstripe, and that adds some interesting things such as preloading tags, HTTP2 headers, and the ability to inline resource content. And again, I've got some examples of where you can use those things a little bit later on. The next one is WebP capability detection. WebP, as I said earlier, is a web-specific image format. It's designed to be a really good mix of quality and speeds, so it's a very efficient module. And a lot of modern browsers, most modern browsers, in fact, now will support WebP. So we've got a module here which just allows us to do a bit of checking to make sure a browser will support WebP before we force WebP upon it. Finally, the image formatter module, Tactica Daniels module, This is actually a really useful, it's one of those really useful little toolbox modules that allows you to change image formats. So whereby we've got this site we were talking about already, which has got a whole bunch of legacy PNG images in it. With the image formatter module, what we can now do is automatically convert them to WebP as the page gets rendered, and it falls just into the normal Silverstripe image class and assets module. So moving on, implementations in the real world. So we've got all of these things. We kind of now know we've got to hit these scores. We've got some basic ideas about what we're going to do, and we've got the tools to make it happen. So really now these are the steps that we've taken to make these things happen. So start off with images, image formats and sizing. So I routinely now use a picture tag as opposed to just an image tag. You can also use image source sets and other things like that. There are lots of ways to do this. This is the one I tend to prefer. So if you're not familiar with it, the picture tag is basically a tag which contains a standard image tag, and you'll see in there we've got an image, we've got a CSS class, we've got a source, and we've also specified the width and the height of the image. I'll come back to that. Also within the picture tag, this is a really simple one. You can make them far more complex than this. I've got a source which says, actually, I've got a WebP version of this image. And that's specified with a source set declaration. And what you'll see in there is just a standard image transformation you're used to in the template. So image, format, WebP. And we get the URL out of that. And that's using the image formatter module. So the browser comes along, tries to load this picture tag and says, oh, it's got a WebP version. I can take WebP, I'll load that instead. So straight away, if you've got a site with a lot of image content, you can greatly reduce the amount of network traffic, the sizes of the images, if you've got big images which would benefit from WebP compression. So that, obviously, as we said before, that gains you a lot in terms of first contentful paint and even first input delay. Just talking about the sizes as well. So we've specified in here a width and a height. Now, these are the actual width and height of the image. As obviously we all know in a responsive page, that doesn't necessarily mean that is the width and the height the image will be rendered on the page. You'll see I've used, for illustration purposes, a bootstrap class in there of image fluid. And that just sets the image to max width 100%. So even though the image may not be rendered at, let's say it's a 800 pixel wide image, even though it may end up being 500 pixels on the screen as it scales up and down, the important thing that adding the width and height attributes does is it tells the browser what shape the image is. So when the browser says, I'm going to fit this 800 pixel image into this 500 pixel box, that means it's going to be 400 pixels high. And I can allocate that space, leave the space in the page, and when the image loads in, it doesn't reflow. So adding image dimensions, it's something I've been guilty of leaving out before because I always thought, oh, that's not needed anymore. With modern CSS, we don't need image dimensions. Actually, we still do need image dimensions because they still, now more than ever, perform a really important task in helping the browser render the page. Background images are a slightly different matter. So if you are using background images, I've sort of tried to format this so it makes a degree of sense. So here we've just got a background image in it, and we're specifying the background image in an inline style. So that data may be coming out of a file object or whatever. And in this case, we're using the WebP support module that was linked in the previous slide. And we're just saying if there's WebP support, spit out a scaled version formatted to WebP. If there's not, just spit out the scaled version. And again, there's all kinds of cleverness you can do. These are the most basic examples just to try and get those ideas across. Now, lazy loading. Lazy loading, as I said before, actually kind of a big deal now. The important thing here is that lazy loading has gained native support in a lot of browsers. And so this is exactly the same image tag as before, but what you'll notice, if you're eagle-eyed, is you'll notice in there's just an additional attribute that says loading equals lazy. And what that tells the browser to do is not to load the image unless it's close to the viewport, unless it's going to be needed fairly soon, just the same way that most lazy loading systems work. It's now browser native. And what's really good is that Silverstripe CMS actually is now adding lazy load support right into the asset management. So that's a really useful thing that will come in. And as I said before, this can affect everything. This can affect CLS, FID, and FCP scores. So reducing the amount of payload that any given page has got to produce is a really good thing. Now, here's where the problem comes. This is the current, I pulled it off this morning just to check, this is the current status of lazy load support across the browsers. What you'll see is that Chrome and Edge both support lazy loading via an attribute for images and iframes. Now, iframes are cool because obviously you've got even less control over what that iframe is pulling in. So if you can lazy load that, that takes a huge burden off of the initial payload. Firefox currently supports lazy loading for images only, not for iframes. The real problem here is Safari. So where browsers don't support it, they just fall back as if it didn't exist and they load stuff in the normal way. So it's not going to break anything. But the problem is not so much Safari on desktop, but Safari on iOS. iOS obviously covers iPhones, iPads, all kinds of things like that. And those quite often represent a big chunk of your audience. So making those users have the lazy load experience it can be quite an important thing. Now, Google, this is Google's recommended way of doing this, like it or not, this is the way they say it. This is how to support IE, because IE also doesn't support it, and particularly Safari. So what you'll see, we've rejigged the image tag a little bit. We've left source attribute to be completely blank, and we've introduced a data attribute called data source, and that's got the image URL in there. Then we just put this little JavaScript snippet in. This again is straight out of Google's web dev files. And it checks to see if a browser supports lazy loading. If it does, it just goes through the entire page and copies the data out of the data attribute into the source attribute and lets the browser do its thing. It lets the browser lazy load, everything will work accordingly. If it doesn't, it injects a lazy load script, so it basically is like a shiv for lazy loading. Injects a lazy load shiv, which just uses the data in the data source attribute to lazy load the images. So this works on images, it doesn't work on iframes, but it is a quick and easy way to get around kind of a polyfill for Safari. Hopefully one of these days they will introduce lazy loading and it'll all be a problem we used to think about. So moving on, redundant code elimination. This is a big one, and this is probably the hardest challenge if you have got a legacy project, you've got an existing project that you want to refactor. I'd say that the greatest gains have always been, that I found, have been in doing the image manipulation, so that's a great place to start. So first things first, be careful about including default framework and library builds. If you use Bootstrap or jQuery or any number of other things, by default, they have these huge toolboxes of really cool things you can use. But if you don't use it, all that's doing is occupying time in your browser for it to parse it, to use it, to set up all of these allocations and functions and all this kind of stuff. So if you don't use these things, don't load them. One thing actually we've been doing lately is moving away completely from some of these libraries. Native JavaScript support is actually now really very good. and you can transpile that using things like Babel to give you backward support. So now in builds, we don't use any jQuery at all. It's all native JavaScript. We use some Bootstrap styles, but again, very little else. So it's something to consider, that actually are these tools which used to solve all these problems, are they still needed? Are they still right? And actually Bootstrap, the latest versions of Bootstrap themselves don't use jQuery. So they've seen that that there may be other ways to do it. Breaking up resources into page and function specific blocks is a big deal. Again, this one's really hard to go back and do later, but as you're building is a really, I found to be a really effective way of doing things. So thinking back to the Silverstripe Requirements class, Requirements allows all kinds of different modules to inject their own little bit of resource as they need it. That means that you have to look at your front-end build in a slightly different way. What you'll see, in just the next slide, is the way that we do that. Some people are going to hate it. That's absolutely fine. Finally, deferring things wherever possible. So if you've got a form that's in the footer of your page, on every single page, you don't need to bind the event listener that submits that via Ajax right at the start of the page load. You can defer that because the chance of somebody getting to that form and submitting it before you've had a chance to do that in a deferred script is very, very small indeed. So anything that you can do that doesn't need to be done immediately, try and defer it. Watch out for race conditions and all those kind of funny things as well. But if you can defer off-screen interactions, again, that really does help with the first input delay, that's all good for performance. So redundant code. This is kind of where I've ended up. You do end up with a lot of files, and as I say, I know some people are going to hate this, but the real world results of this actually are proving quite good, and it's obviously always evolving. So ultimately, in a typical project, we might have these are the JavaScript sources, and in there you'll see there are specific JavaScript files for a map element, a service element. There's a common JavaScript file, there's a core file, there are form handlers. So there are all these little micro chunks of scripts. And depending on what the demands of a given page are, that actually dictates what gets loaded. Exactly the same with the CSS files. So this is obviously SCSS source. You'll see each element has got a specific set of CSS that is specific only to that element. There are also page-specific CSS files. So if you've got a particular page template that's got styles which are only used on that page, they're loaded via a specific resource file. In terms of the actual pipeline, I use Gulp. I find that it lends itself much more easily to this approach of asset building than something like Webpack does. And kind of the move here is to get away from big monolithic application scripts and big monolithic application style sheets. It's set up to build very, very targeted CSS and JavaScript files so that for any given page, the ultimate aim is that on any given page, there is no unused CSS and there is no unused script. That's the holy grail of this, because that makes everything on the page relevant, and that means that all of those scores are going to reflect that. So this is, as I say, this is just a simple snippet of my Gulp script. It's doing various things. It's just outputting a whole bunch of files. You don't need to teach you how to use Gulp. Obviously, with all these much smaller files, you can choose to inline some of them as well. Again, that's a bit of a balancing act between how often you think they're going to be needed, and hence whether the browser cached version is going to be useful and how quickly you want to get them executed, whereas an inline, small inline script is often better to do that. Prioritizing visible content, we touched on earlier on as well. And this is something which we found works really well. So core CSS, stuff which is critical to that first view, if you move that CSS inline, the browser can get on with that as soon as possible. It doesn't need to wait for a file to download. There's no network issues there. It can get in there and start rendering that. You've got to be really careful not to put too much into this, because obviously it's not cached. It's loaded on every page. So that adds to your page payload a little bit. Now this could be things, for example, this is a little snippet. This is just setting a couple of key HTML properties, and then it's setting up a nav bar, some nav holders, things like that. So these are the things which we've inlined in the script. So it's there right away. So as soon as the browser has got the page structure, it can start to render it. It doesn't need to wait for anything else to happen. Another place where inlining CSS can work really well is if, for example, you're using Elemental and you may have a hero image that's always going to appear at the top of the page. If you inline that CSS as part of the element controller, again, the browser can get on and render it fast and give you a really quick LCP time, which is, again, what we really want to do. The way we do that, this is some of the functionality we added to the enhanced requirements module. Now, if you're familiar with these, you'll see you've got a requirements call, path to the file, and then you've got the options array at the end. That's normally got out of the box things like setting async and defer, that kind of stuff. What we've done here is added a few extra bits and pieces. There's an inline flag, which is what these two have been set to. So there's a core JavaScript and a core CSS. We want those in the page right from minute one. Doing it this way means you can still build those scripts in your build pipeline. So rather than using custom script and adding that into the PHP code, you can build your scripts using Gulp, Webpack, or whatever it may be. You can still minify them, you can still auto prefix them and all those cool things, but this will then drag them in and inline them into the page. So again, use with caution, but this can be a really good way to reduce your FCP scores. Preload and pushing. Now this is a bit of a kitchen sink method out of a page controller. And what you'll see here is hopefully a lot of this is actually self-explanatory. So we're adding in a couple of pre-connect tags into the page. We're injecting those using another requirements method, which is insert head tags. And what those tell the browser is that actually you should start, as soon as you possibly can, make a connection, do the DNS lookups, all that kind of stuff, to, in this case, Typekit, because we're going to be using some assets from there. We then do a CSS, in this case, to the Typekit style sheet. And you'll see on that line there is a preload true. So there's an option in there for preload. What that does is that injects a preload tag into the head. So again, to tell the browser, as soon as you're able to, get hold of this spreadsheet, give this priority, because it's going to affect things right across the page. We've then got a couple of fairly standard JavaScript calls that just get loaded in normal time. We've got a CSS link, which is common.css. So in this case, common.css is stuff which is common to every single page on the site. We know it's going to be used. It may contain stuff like your layout grid, it may contain footer styles, it may contain all of those kind of things, which you want to keep in a file so that you can cache it, the browser can cache it, but aren't necessarily needed for that core rendering at the top that we looked at just a second ago. In this case, we've added a push option in the options array, and what push does is if your server and your hosting environment supports it, this is a signal to the server to actually send this resource to the browser, whether they've asked for it or not. So this is us saying we know that the browser is going to want this, even though it hasn't asked for it. It might not even know it yet. Send it anyway. So when it's there, the browser doesn't have to actually think about that. It's already been given it. Obviously, that is all dependent on your hosting environment, your browser supporting HTTP2 and all kinds of other things. But it's quite ubiquitous now. It's about. We've also then got, again, a few other things. The core JavaScript, the lazy load JavaScript we showed earlier on, and the core CSS, they're all set to inline. So those are things we want in the page. We want them to execute at the earliest possible moment within the page building process. And that's where the inline trim comes. And then we've also got the core and the common JavaScript files. The common JavaScript files, that's again using a standard requirements call, and we're making that async, and we're deferring its execution as well. So we're doing everything we can just to get that out of the way and only actually execute it when we need. One little caveat to this: preloading and pushing and all these kind of things. It's very easy to say, all right, excellent, that's such a good idea. I'm just going to preload stuff. I'm going to push everything down with HTTP to, I'm going to preload everything, and it's going to be great. It actually has the opposite effect, because you go from something where you're just letting the browser do its own thing, you're not telling it, giving it any hints, the browser will work it out, to a thing where you're actually saying to the browser, everything's important, load it all. And the browser doesn't know what to do with that, so it kind of just defaults back to going, well, I'll work out what's important, because you told me everything is. So you have to think about which things are actually important for your given page and for your particular environment. And that's where the requirements class really comes into its own, because you can make decisions in your application logic as to what resources are going to be needed. So after all that, the bottom line is that you shouldn't take my word for any of this. There are no two sites that are the same. Every site I've worked on will be different from every site you're going to work on. So there's no silver bullet solution to this. It's the same as anything. And the process is really, really straightforward. It's what we do all the time. Make some adjustments, test it, repeat. Go back and forth until you find the most optimal solution. And this is where actually we've done a lot of work with clients who may have maintenance contracts, or it's a good way to actually go back to a client and say, actually, there are some new things out there now that can improve your performance, and we know they're going to improve your SEO work as well. So let's have a look at it. Let's have a conversation about it. After you've done all that, probably the most important thing is to revisit this after your site has had the client loose on it, because it's quite possible they have gone and uploaded 13 megabytes of PNG images onto their page without really thinking about it, and you need to make sure that what you're doing is actually making a difference. So that's it. That's really all there is to it. Core Web Vitals, as I say, broken down into these three key areas: how fast it loads, how fast it renders, how fast you can interact with it, and how stable it is visually. And these things do have a significant effect both on real user experience. You find that once you've done this, web pages do feel snappier, they feel quicker. And it also has a real impact on your page experience scores, and that ultimately is what Google likes. So happy optimizing. Hopefully you'll be seeing a few of those. If you've got any questions, obviously ask them now. I'll be around in Slack, obviously, all for the rest of the day as well. And yeah, that's about me. Hopefully Andy is going to appear any second, magically, somewhere. Yes.
Thank you very much, Tim. That was very interesting and very nice optimization topic here. Are there any questions? I think everyone has to take a measure now.
I think they've all fallen asleep. I think that's the problem.
Yeah. No, not really. But okay, we know how to reach you. So let's continue the discussion in Slack. Oh, there's a question from Bryn from New Zealand. No, that was
Well, combined files. So what about combined files? Yeah, I mean, essentially the answer is I never use them because combine files is effectively exactly the opposite of what I've been trying to achieve here, which is to make the resources on any given site really, really granular. So adding combined files to me makes no sense anymore. To achieve these things, we found it's much better to be really specific about what gets included in the files and loading them only when they're needed.
Okay. And then there's the question from New Zealand, from Bryn. Yes. Okay. So how often do you find that clients are bringing the page insight data to you, and how motivated are they?
Yeah, I mean, actually, as I mentioned, what really kicked this off, I mean, we'd heard about this, we'd started seeing these scores in page speed and so forth. At that point, it was an easy thing for us on new projects, because we recognised obviously fairly quickly that this was going to be important. So we shifted new projects. But where this has really taken off is, as I said, is actually this data is appearing in Search Console and Analytics, and our customers are then saying, well, what's this all about? Why is this graph so low? We want this graph higher. It needs to be higher. We like high scores. So it was a really good way to start the conversation with clients, and where it's been the most successful are on probably more mature sites where their focus is very much more on SEO, where they're fighting hard, where they're in particularly competitive environments, and they're kind of looking for any advantage. So I think, yeah, compared to new features, probably not. They would they'll always want the new features first. But again, what we'll tend to do is we'll try and introduce it ourselves. So if we've got a client that says, oh, we want to add this really new cool thing, we'll say, yes, that's great, we can do that. At the same time, whilst we're rebuilding stuff, whilst we're deploying, we can do these cool things to improve your performance as well. So it's very much an incremental process, I think.
Yes, I think that's the right way. Thank you very much, and I see you at the bar later on.
I certainly hope so.
Then in Slack.
Absolutely.
Thank you very much.
Thanks a lot.